And welcome to today's webinar, where we'll be taking a look at the energy performance gap between predicted and actual energy use in buildings and what will be done about it. My name is Stephen Kennett, and I look after the built environment and energy portfolio here at 2 Degrees. I'm delighted to welcome our presenters today. We have Paul Roosevelt, Professor of Energy and Building Performance at the UCL Energy Institute, who's going to kick things off with an overview of the CarbonBuzz initiative. And for Paul, we have Joe Jack Williams of Architects Field and Clegg Bradley Studios, who's going to take a look at how they're using the CarbonBuzz initiative to evaluate their projects and also explore a number of case studies. The presentations will last for around 40 minutes, which will leave us with 10 minutes for questions at the end. Before we begin, I'd just like to remind everyone that you can submit questions throughout the webinar using the Q&A box on the bottom right-hand side of the screen. Just type your question and press send, and we'll wait until the end before answering as many as we can. As an aside, if you have any technical issues during the presentation, please use the chat box on the right-hand side to send me a message, and I'll get back to you as soon as I can. Without any further delay, I'd like to hand over to Paul, who'll get us started with today's presentation. So over to you, Paul.
Thank you, Stephen. Good afternoon, everybody. It's a pleasure to introduce to you CarbonBuzz and talk about the work we've been doing to develop CarbonBuzz in order to help close the gap between design predictions of energy performance and the reality of occupied buildings. I'd like to start with a brief introduction to CarbonBuzz in terms of where it came from and what it can do. I'd then like to talk a little bit more about the functionality that exists on the home page. And lastly, I'd like to talk through just entering some data CarbonBuzz to show how you can get meaningful results quite quickly. So CarbonBuzz is a collaborative project that's actually about 8 years old from its inception and has involved a number of parties actually active in the construction and building operation market. The whole concept is to develop a platform which allows people to upload and compare data for different building types and to understand how the performance of buildings is happening over time, but also to be able to compare the performance of their buildings to other similar buildings. And one of the things that we face in the construction field and in building operations is that we have many different types of requirements imposed on us and many different reporting systems, from energy certificates to energy performance certificates, requirements, CRC and Part L. Essentially, we often find ourselves comparing not just apples and pears, but this whole variety of fruit that you can see on your screen now. And when we do this, things get missed. Portions of the actual energy use in buildings are not always predicted, for instance, at the design stage. This leads to the sorts of performance gaps that we can see here, and this is data taken from CarbonBuzz a little while ago, and it shows left-hand bars in each case the design predictions for a group of buildings. On the right-hand bars, the mean of the actual energy use. And you can see in education there's quite a disparity. Retail and health seem to be closer, but there are large disparities in other sectors as well. So CarbonBuzz endeavors to identify within the data that is placed in it what components of energy use are actually being recorded at any point, whether it's simply the compliance energy use, as you would do through Part L, or indeed whether it includes other things like plug loads, IT, occupancy factors, and so forth. And with the platform, we now have a number of organizations who have uploaded portfolios of buildings that can be viewed, and I'll say a little bit more about this in a moment. But one of the larger portfolios and more detailed portfolios is the Technology Strategy Board's building performance evaluation case studies. These are quite interesting because these buildings have been monitored in some detail. The intention of developing CarbonBuzz actually aligns with the modern concept of BIM, actually allowing data drops to occur at various points through the design and ultimately the operation of the building, so that the actual prediction of energy performance can be tracked from inception through to operation. Using CarbonBuzz, there are several things that an organization can do. Clearly, you can load data and store it so that it's simply a repository, but you also share that data within your organization and beyond. You can compare that data to other buildings that exist either anonymously or as case studies. Use the platform to refine predictions as you go forward and to track the performance of the building. And you can also use it to generate a series of reports about the portfolio of buildings that you have. So I'd like to now move to the homepage functionality. We've done the homepage quite recently, so that before you log in, there are a number of things that you can actually do. The first is to look at some of the case studies which simply revolve on the front page and go into more detail on those to see the design energy predictions, the actual energy use in comparison with the CIBSE benchmark targets, and drill down even further and look at individual records and look at those in even more detail. And by clicking the button at the right-hand top corner, you can do some analysis and compare one of those records to a collection of other buildings which you produce by setting a set of filters. You can do that in more detail still. A moment ago that there are a series of portfolios of buildings within the within the platform. These are accessible through the home page, so that you don't need to log on to see these buildings. And again, drill down into those portfolios, into individual buildings, sort them in various ways. So if I'd like to just take you through steps to uploading a building and hopefully demonstrate to you how easy that is and how quickly you can obtain some meaningful returns from CarbonBuzz. So once you've registered and got your login details, you're presented with a dashboard. This is one of my cost dashboards. She has 3 buildings uploaded, but wanted to add a new building. She would simply use the Add New button. Presented with this form, which is the project details form. And there are only actually 6 bits of information here that are mandatory. So you can see that it's very quick to get started with a single building. That can produce a project outline, and automatically included in that, if you've given the building type and so forth, will be the CIBSE benchmark for that building. You can add a new record. A record can be a design prediction, or it can be a record of actual energy use. In this case, we're entering measured energy use from energy bills, as you can see, and we simply call it demo record. And because entering a measured energy use, the automatic assumption includes all the different components of energy use in a building, so including plug loads, IT, and occupancy, and so forth. If for any reason you knew that any of these components was excluded by being separately submetered or something, you could simply tick to exclude them. You'll see some buttons at the very top here, and what they do is tell you which components of the description are complete. So we have an orange here with a tick, which means that's complete. The reds here mean that these are not fully complete, or haven't been signed off yet. 2 types of information that you need. There's mandatory information, which you can't progress without including, and desirable completeness information. So that allows people, when they're searching records, to understand which records have been complete to a reasonable level of detail. And that's, as you can see, shown on this slide here. So this one says it's 27 complete. All mandatory are completed, but not all of the components for what we would describe as completeness. And as I said, all of the various components are assumed to be included in a measured energy consumption unless any of them are excluded by the user. You then simply need to enter the electricity and gas consumption, and this can be per meter bed or total for the building, and there are various other fuel uses that you can enter, but electricity and gas are the typical figures that you would put in. That will bring you up an energy bar that you can immediately compare with the CIBSE benchmark, broken down into total electricity and total gas, and you can express that in a number of ways, kilowatt hours or kilograms of CO2 and so forth. And you can immediately then compare that with your own portfolio or a wider portfolio of buildings of that particular type by using the analysis button, which leads through to the search and filtering process. So that's a quick through the CarbonBuzz platform in terms of its homepage and its basic functionality. I'll hand over to Joe now, who'll take you through some project examples, and then of course I'd be happy to answer some questions later on. Thank you very much.
Thank you much, Paul. So I'll just bring up Joe's presentation and hand over to you, Joe.
Hi, as Stephen said, my name is Joe Williams. I'm from Phil and Clegg Bradley Studios, or FCB for short. I'm just going to run through quickly how we use CarbonBuzz as an architectural practice, and hopefully show you some of the sort of benefits of getting your data in there. So just a quick background of FCB for those who aren't familiar. We're a medium-sized architectural practice, about 130 members of staff. Been going for about 30, 35 years, and we'd like to think of ourselves as a leading sustainability practice, pushing this other sustainability for the last 20, 25 years. That's sort of how we got involved with CarbonBuzz right at the start. We've been sat in a partnership with it for, I think, 6 years. So the main way that we actually use CarbonBuzz is just as a repository for all our data. Means we can quickly compare all our data with other benchmarks. So just to show you here, so we've got about 20 projects at the minute loaded into CarbonBuzz in various states. You can see some of them, most of them have got design data, and there's quite a few with actual data as well. And this allows you can see using data from this, but actually from this, there's a mix of projects and building types. We've got schools, we've got libraries, we've got museums, we've got student accommodation. So there's not really a great deal we can get from this. So CarbonBuzz actually produced a portfolio for us, and we can add projects to it as and when we need it. So this is just our schools list. I'm a space research for schools. This is obviously right on my ears, as we say. So there are schools here. Just predicted energy use for each of these buildings. And we can start to see actually around the same sort of area generally, which is good. So we can see, generally the data's okay. We've got a couple of outliers actually. We've got Tizu School at the top, and we've got this Hastings Academy right at the bottom there, which is looking quite suspicious. I mean, well, no, we've got a low energy school, and we're good, but that's suspiciously good. So what we start to do from here is we can start to look into this and find out why it's so good. I mean, initially we can see there's no red bar indicating there's no thermal energy there. So there's something obviously going wrong. So if we have a quick look at the end use, you can see from this, actually we've got the breakdowns of all the energy And we see the Hastings Academy at the bottom there. There's no space heating at all incorporated into it. Now, it might well be there's no space heating, but I think it's pretty unlikely. It's a school, it's going to have some form of heating in there. So, there's been a mistake here. Either it's through user error or it's through the engineers have overlooked some area of the energy use. But it's an instant, we can see it clearly that there's an issue here, and we can flag this straight back up to the engineers and say, look, what's going here? Is this correct? And it just gives us that little bit of extra confidence that we know the data we're getting and the buildings we're building are actually usable buildings. Another thing you can see from this as well when we look at the energy use, this Aston University Engineering Academy in the middle. We can see it's ground out. And this is actually because we don't have the breakdown of energy data. We only have the raw utility energy data, if you like. So we can see, although we don't have the breakdowns, it's in the sort of ballpark of the rest of the projects. So there's probably something to worry about from our point of view, but we'd like to see what the breakdown is and make sure this is working correctly. So that's very quickly, we can see even our engineers, if you like, and also from the architect's point of view, who are maybe not as well versed with the energy side, we can see that what we need asking of the engineers, a bit more direct questions, just to make things a bit quicker. The real benefit of CarbonBuzz is comparing against benchmarks. As Paul mentioned earlier, we've got the CIBSE T46 benchmarks built into CarbonBuzz. We can see straight away how they compare, but it's always good to have an external benchmark. It gives the a bit of competition, a bit of peer pressure for the design teams. So this is one of our schools, which is actually part of the Tech Strategy Board's Building Performance Evaluation Program, and we can see the energy use prediction from the engineers there. There's about over half of the TM46 benchmark figures, which is it's great. We'd be seeing it much lower than half, to be honest. So we can down by looking at the end use of the fuels to see exactly what's happened here. See, there's quite space heating, and there's quite ICT infrastructure. It's a modern school, not a surprise. It's got a lot of ICT, and the heating's not too bad, but it's all just generally a little bit too large. Now, I haven't included a slide, unfortunately, but if we look to the CO2 rather than the kilowatt hours as I am here, the biomass boiler here will take it much further down. So you can look at it from this simple kilowatt hour point of view. Okay, we can always look at it from the sort of carbon point of view as well. Compared against CIBSE TM46 is good, and TM46 is valuable in comparing buildings in a very quick manner. But in the infinitely updated, and it's based on limited number of buildings. And the real power of CarbonBuzz is we start to look at the large data sets that are in CarbonBuzz, and we can start to then compare projects comparing against projects and all our peers, and that's one of the massive benefits. So if we have this, and we paused earlier with a screenshot from CarbonBuzz, there are 9 school buildings in here, and we can see that that green dotted line is actually the benchmark from CarbonBuzz for all the school buildings. And we can see, it's been too great. I mean, we've got 7 lower, but as engineers, we like to think of ourselves as sustainable architects. We're not doing as well as we hoped, and we've got 2 over the benchmark. It's a bit of a prize, really. I'll come back to this very high one on the right. So, we can see instantly that, although okay, we could be better. There's other projects certainly using much less. I think there's one right down the end there which looks to be using 0. So there's definitely a bit of aspirational work there. What's the actual? Let me see, actually, there's some very high spikes on the right, just throwing it out a bit. UCL's bit of work on bringing some of this data down a bit and having a look at erroneous data. What we can see for the schools with actual data in from our earlier portfolio are way below the actual benchmark. This is quite robust of the schools, the Education Funding Agency, of all their school data in there. So we know we're doing okay. We're about average. We're on that sort of dual plateau. We'd much prefer to see that further down, which is something we can start to look at in detail a bit further. If you look at the Thamesview School. So Thamesview School is the high outlier on the previous design slide. And we see the book prediction, energy use prediction. The bottom bar is actually quite a large bar. 3/4 of the benchmark energy use. We usually expect to see much lower than this. Quite interesting. This is a PFI school building, so they've done their logbook prediction for energy use, which is quite high, knowing full well that there'll be some questions coming back if they're not meeting their targets. As my evaluation, I'm their energy use using their submeters. You can see actually slightly below prediction, which is great news. There's some questions about how they actually predicted the energy use in the first place and whether accuracy is there. And we can start to sort of have interesting questions of them team and the PFI companies to find out what's going on. Well, I can't take it away from them. They're doing better than they predicted, so good on them. Another project here, this is the Hive. We've got POE undergoing at the Hive at the minute with Max Fordham's, and we'll be getting the data as it progresses. But we've got about a year's worth of utility bills. Interesting here, something the current functionality of Buzz from the platforms is we've got two different design sets. We've got the as-built EPC, and we've got this EPC plus unregulated. This is where Max Fordham's have estimated the energy use for power. Things like desktop lamps and things be left on standby. They use their proprietary spreadsheet tools to find this out. But we can see actually, they do a pretty good job of guessing where use is going to be. If you look at the utility bills, there's not a huge gap between the two of them. Better than the first year of building occupation, so we expect there to be some settling in of building services and the control systems. The FM team get up to speed with how they're going to use the building, how the building is designed to be used, and what's the sort of mismatch. Another really draw from this is actually this as-built EPC, really very good indicator of the energy use. And this has been sort of known and talked about for a while, but actually it's a really good graphic to be able to see just the discrepancy between the two. And again, we've got this compared to the TM46 benchmark. So we can see we're still doing okay against the benchmark. But again, we look at it in the bottom half rather than just over half. Looking at this National Trust headquarters, this is another technology strategy board building evaluation project. This, I think, was undertaken by the board again. And we can see here, this is a bit more typical of many of the projects we see within CarbonBuzz. And we have this energy prediction, which is a bespoke one done by the engineers behind the project, and the 22 analysis. And there's probably, it's not 100% out. It's down to this huge amount of heating discrepancy, and the ICT, actually, as well as the lighting. Although it's a small amount, it's still quite a considerable proportion out. Interesting to see from this is actually zero carbon electricity, about another amount. So despite the use going up, there's still a thing good to be taken away from this. But what we then do with this data we have here is to feed this back straight to the FM team online, either through CarbonBuzz itself by sharing the record, or actually just print this out and showing them a lift control strategy and your heating and your ICT, and let's have a think about how we can improve this further, because it's quite a substantial operating of servicing energy. So there's definitely something of interest there for the FM team. But it's not an unusual thing to see such a massive performance gap between the two. what we see here, this is from the old platform before the new released fee scale. It shows the discrepancy between the original energy use and the actual energy use. We see, although our schools are not performing as we liked, there's no real surprise there that the two dotted lines are showing the benchmark medians there. So we can see, all those are being under if you like, under need. The universities are struggling significantly to predict what their energy use is, and that's probably down to their uses. But even where it's a bit more straightforward, you have multiple office hours. We're still struggling to see what the gap is. So that's really how we use it, and I think of the time, but this is how we use FCB. Thanks for your time. If there are any further questions, feel free to email me at jw@fcbstudios.com, but I think we've got quite a bit of time to go through some questions now. Thanks.
Great, Joe. So great sort of overview there of how you're using the tool. So we've got plenty of questions come in, and I guess one that would be good to start off with, and Paul, maybe if you want to tackle this one first, but someone is asking, how might an end user or occupier use CarbonBuzz and the data on it? Is it something which they should maybe be using to inform decisions around upgrades and refurbs?
There's ways an end user could use CarbonBuzz. At a very basic level, somebody operating a number of buildings could use it as a platform which to store the annual measured energy use of those buildings and share that information with other members of the team. And obviously, in subsequent years, the annual performance could be updated and one could track trends and so forth. Immediately you upload any data, you can compare it to the other data that exist within CarbonBuzz, so that if there are similar buildings, say offices or university buildings or whatever it is, you can compare the building you've uploaded to the ones that already exist in the database and see where you are in relation to the range of energy performance. You can obviously use the tool to track a project before and after a retrofit, and we've got at least one client who's just uploaded some 30 buildings, primarily because they intend to enter into a retrofit program and they want to track the performance before and afterwards. Then the last question about can you use CarbonBuzz to try and identify the strategies that you use in retrofit. That's ultimately where we want to get to. Design the search and filtering system to allow you to isolate particular features and so forth within a building, so that you can see those buildings that are performing well and those buildings that are performing less well, and track back to some of the features that lead to those differences in performances. I have to be fair, the ability to do that will depend upon the quantity of data with CarbonBuzz. At the moment we have some 800 buildings in there and 200 registered organisations using the platform, probably of the order of 600 or 700 actual individuals. So we're hopeful that over the coming months that number will grow, and therefore the use of the platform as a comparison tool will become more powerful.
Thank you, Paul. Actually, one question we had in was how many buildings you've actually got registered on the tool, and obviously you've just mentioned 800. But are there particular sectors which are particularly well represented?
Yeah, it's fair to say that the best represented sectors at the moment are offices and schools. Then the sort of remaining sectors have probably an equal share of projects, probably of the order of only 20 or 30% of the number that are in for offices and schools at the present time.
Thanks, Paul. So somebody else is asking, what level of detail of data are you gathering? So there's actually a couple of questions people have sent around that. So how much data would you need to input to kind of really drill down into the detail of where the energy is being used?
Okay. Well, of a design stage, you will have, if it's a non-domestic building, then typically have some sort of design stage prediction that will often break the energy use down into component parts so that you can enter that into the platform. It will not typically include the unregulated energy uses of computers and IT and so forth, and as just mentioning, some engineers now are going the extra step and attempting to model or calculate those unregulated uses as well to get a better overall prediction. Operational stage with buildings, then the amount of data that you can put in obviously rather depends on the amount of data that you've got. For most buildings operating today, total energy consumption for gas and electricity will be relatively straightforward to get hold of. For buildings, obviously we have the requirement now for sub-metering in larger buildings, and increasingly that sub-metering will help break down energy use, and that can also be entered into the platform. As Joe said in his presentation, you can also enter the data from CIBSE TM22 analysis, which is an analysis technique that allows you to break down energy into individual end uses like lighting, heating, and so forth, even if you don't have sub-metering.
Just like to add in there as well, it can be quite tricky to get this energy data from some of the sub-meters, and a lot of the involved who have this have been involved in a speed project, but as Paul mentioned, with these newer buildings coming out with this sub-metering, it's becoming easier and easier. It's quite difficult to retrofit these systems, but inside of a project, if a new building being built, just make sure that you're aware of the value of having these sub-meters and ensure that they're kept on top of, I suppose.
Great, thanks, Joe. Another question is data anonymized when it's put into the platform?
Question. Obviously, a lot of people are concerned about this. I should say that the whole platform has been developed to a high level of security in terms of access to the data. And when you register as a user and enter your buildings, then the information about those buildings is held completely anonymously. The only thing that is released into the platform for others to look at is the fact that a building exists of a particular floor area, of a particular type, with this level of energy consumption. So there's no identifier that takes it back to the building or its location or like that. So and this is the power of the database, really, that an individual can use it to track their own buildings and understand them and know them in detail, and they also compare it to a great wealth of other data about which you can tell some of the characteristics, but also you cannot actually identify any of those individual buildings unless, of course, the owners of that data want to release it. And on the platform, a number of organizations have decided that they would like to release the information on their buildings as case studies, and then always, because they're fantastic buildings, a lot of owners are quite keen to have their data out there so that others can learn from it.
Thank you, Paul. Another question, is it just UK-based properties which are included in the database, or further afield, and also all are plans to include buildings from across Europe?
Okay, right one for me again. So it's UK-based, and there are a couple of reasons for that. the main being that in using the benchmarks, we're using the CIBSE benchmarks for UK buildings, so the comparison is essentially set up for UK. And also in displaying the carbon dioxide figures, we're using the UK carbon factors. We have a tremendous amount of interest in the platform from overseas, and at the present time we're trying to figure out how we respond to that, because it obviously does require some development on things like benchmarks and different carbon factors, as well as some other features. Obviously, other countries don't operate the same building regulation systems that we operate and so forth. They don't have EPCs in exactly the same form that we have them in. So there would be quite some changes to be made, but it's something that we're actively looking at.
Thanks. Joe, here's a question for you. Do you find that there are tensions between the different parties, so the professional design team, the owners, the FM contractors, to understand the reasons behind and bridging the performance gap?
Yes, ultimately. I'd love to say there wasn't. It's understandable. I think construction as an industry has not been good at evaluating how they performed until very recently. And I think now we're trying to bridge this more actively. There's always going to be an element of resistance. There's certainly concerns over this action, whether people are finding out their building isn't performed as well, and is there going to be some sort of comeback to the designers. But actually, when broaching this, and certainly with the occupancy evaluations I do, as long as you sort of broach it in an open mind fashion, not apportioning blame to teams, but using it as a tool to find out how we can improve the next generation of buildings, and also how we can improve the building stands, then actually most of the sort of parties involved seem to sort of ease up and line up. I mean, still, certainly 5 projects, there can still be some issues with confidentiality, and that they seem to be the most, not confrontational, but certainly the most tension between groups. When most buildings are just happy to have other people looking at the building and giving them advice on how to reduce energy costs. Certainly, some of the schools I'm looking at, they're very keen to have other people advise to see if they can reduce energy down. I think, generally lots of tension, but it soon diffuses when they see the benefits for them and us doing a detailed study.
Great, thanks, Joe. I'm conscious of time, but I think we've probably got enough for a couple more questions. And Paul, if you want to tackle this one, but are there any health warnings when interpreting the data that people should be aware of?
Yes, and just go back to those points that I was making earlier in my presentation, where we have an indicator of the completeness of a record. And when people then search the records, this is reflected in a data quality indicator. So very simple level, the more complete the record, the higher quality the indicator is. So that gives you some idea, basically, of how diligent people have been in filling in all the fields. But of course, it doesn't necessarily mean the fields themselves or the data that's entered has been accurate. That's a challenge, because you're obviously relying on individual participants in the platform entry data. We'll ask them the sources for different data. So, for instance, if it is coming from a display certificate, then that's quite a good data source, because it has to be done to a particular standard, as does an EPC. Prediction is necessarily very good, but it's been done to a particular standard of calculation and so forth. Also, taking their floor area from one of those certified sources, that gives you more comfort that it is a realistic floor area. And that's obviously quite an important factor, because in comparing buildings with each other, we're comparing them in terms of kilowatt hours or kilograms of square meter per gross into floor area. And of course, if floor area is wrong, then those calculations are wrong. So I won't say it's perfect because it is very subject to the accuracy with which individuals enter the data, but at least there are there is some ability to check the level of completeness and understand what sources are being used for the data.
Just to add on to that, Paul, a lot of time has been spent on making the interface for CarbonBuzz to make it as user-friendly and intuitive as possible, reducing issues of entering numbers. So there are only just in the general layout of it, assistance for the user to understand how they're entering the data, and that reduces any issues with the data quality in itself.
Joe. Just one final question then. Somebody's asking, how does it account for occupancy patterns? So they say that if you're sort of sweating the asset and you've got a high occupancy density, is that taken into account?
So we're talking about looking at a building that's operating, then we automatically assume that measured energy consumption obviously reflects a particular occupancy pattern. Now, CarbonBuzz doesn't have any predefined occupancy patterns within it for any particular building type, but there are facilities within the platform to add commentary to the extent of, this building is operated 7 or 18 hours a day, 6 days a week, so that one can see an explanation behind the fact that a building may be more intensively used and might explain where it sits in relation to its peers and where it sits in relation to its benchmark. But at the moment, there aren't any systems to deal with that.
Thank you for that. So I'm afraid that's all we've got time for now, but I'd like to thank Paul and Joe for their time today and for getting through so many questions, and also for everyone who joined us for this webinar. Recording of the webinar and the presentation slides will be archived on the 2 Degrees platform. Found today interesting and useful, and that you'll be able to join us for more webinars in the coming weeks. So thank you.
Thanks, Stephen.